Okay. So this one is about electric. Okay. Figure 7.1 shows 3 identical lamps and an ammeter connected to a power supply. Jadi apa yang dulu yang kita tahu nak buat soalan ni? Okay, you kena recall balik. Saya pergi. Tahu? So dah kena tahu lah by now. So, bila ada series, what are the things that you need to know? And then bila parallel, what are the things you need to know? Okay, dah ingat dah benda ni. Kalau awak tahu ni, so no problem. Any kind of questions, you boleh answer, you boleh calculate. Okay, so let's go back to this question. The switches are closed. Each lamp is rated at 60 watts and operates at its normal working voltage of 110 volts. Calculate the current in each lamp. Siapa dah dapat jawapan berapa? What's the answer? So how do you do this? Yang ni boleh tak awak gunakan P equals to VI, IV? Tak boleh kan? P pula, sorry. Boleh tak you guna equation V equals to IR ataupun you tengok series and parallel ni boleh guna tak? Tak boleh kan sebab you don't know the resistance. Okay, tengok ni formula ni. Okay, Q equals to IT. What is Q? Q is charge. Do you know charge here? Tak boleh juga. So awak tak boleh guna. Okay, and then Q equals to IT. Sama juga. Kita nak cari, kita ingat, oh bolehlah guna ni Q equals to IT and then I Q over T. Oops, you don't know the time, you don't know the charge. Tak boleh juga guna. Tak boleh, tak boleh, tak boleh, tak boleh. Okay, and then apa yang kita tahu? E equals to PT. Tak boleh, you don't have the time. Again, E equals to VQ, don't know the energy. So finally, we are left with P equals to IV. What is P? P is the power. So power is given here. How do you know this is power? Dia kata power lamp, each lamp is rated 60 watt. So you kena tahu watt ni adalah unit for power. Okay, and operates at normal working voltage so this is the voltage. So now you have this both and you write down the, okay, what do you want? You want?
Current.
Okay, so kita rearrange, therefore I equals to P over V. So the power is 60 watts, the voltage is 100. And kita tekanlah calculator, tolong tekankan, what do you get? So do you need to know the unit for current? Yes. Kalau tak ingat, awak letak je W over V. Kalau awak ingat, awak letaklah what's the unit yang awak tahu.
0.54.
Ya, jawapannya 0.54 ke?
55.
Salah. 545 ataupun 0.55. Okay, be careful. Be careful bila round off tu. Okay, kalau awak round jadi jawapan 0.54 ni dah salah. Sebab kat belakang ni 5 kan. Dia sama ada jawapan dia 0.55 ataupun it's good if you write 0.545. Unit atau tak unit? What's the unit? So the unit is ampere. You don't know the unit, you write this. Kalau awak tak tahu unit dia, you can just write 0.545. Okay, alright, next. Current in the ammeter. So where is the ammeter? So here, the ammeter is here. The ammeter is placed in series with all of them. Dengan semua bulbs tu. So this is actually measuring the total current. Tengok ni. You are actually measuring the I total. Jadi kalau I total, so whatever the current here is, kat sini ada current flow kan? Contohlah current flow kat sini, current flow kat sini. And then junction, we have 3 different junctions. And then when you enter the, you get out from the junction kan? Keluar daripada junction tu, dia akan combine all the, you will combine all the current study from the different junctions. Jadi perlu kira apa-apa tak kat sini? Tak perlu. Macam mana awak nak dapatkan jawapan dia? Jadi kat sini, current in each lamp is given as 0.545. Jadi kat sini kita nak buat apa ni? Kita nak total current kan? What you need to do? Ingat tak? Tak buat lagi tak apa. Tapi kalau ingat, you boleh tak bagi tahu saya? Ni kalau soalan exam lah kan? What do we need to do in order to get this current IT tu? Alamak, tak ada orang respon. Jadi kan kat sini ni. Kita kena tengok di sini. Okay, now this is in parallel. Tapi kita nak dia total. Total dekat mana? Nampak tak macam sama gambar ni? Macam sama walaupun tak sama lah. Kan? Nampak tak? On the right side punya diagram and the question punya diagram. So, what do you want? Now you want the total current. So, what you need to do? Do you know the current at each junction? Yes, you know.
Yes.
Each junction, value current dia berapa?
0.545.
0.545, 0.545. So what do you think will be here? Here. So what you will do? I
Yes.
want, you tambahkan saja. Lepas tu, plus 3, jadi berapa? Ataupun darabkan 3 kan? So dapatlah 0.545 times 3, so dapat 1.635. Jadi jawapan awak berapa? 1.635. Cikgu nak tulis berapa? Tulis 2 decimal places ataupun 3. Tapi kalau nak tulis 2 decimal places, make sure you got that right lah. Okay. So kalau awak tulis 1.63 betul tak? Salah.
Salah.
Tuliskan 1.64. Now the voltage. Macam mana pula the voltage? Masih lagi 1 mark. Still 1 mark. So where is the voltage? Jadi kalau saya nak letak voltmeter, dia kata dia nak the voltage of power supply. Power supply. So if I want to draw, kalau soalan kata draw the voltmeter. So where will you draw the voltmeter? Is it here? Ataupun tak kat mana? Sini? Tak kan? So kita nak power supply, kita letaklah dekat sini. Actually, you can also draw here. Kat sini pun betul. Ni. Kenapa sini pun betul? Okay, sini pun betul sebab apa? This is in parallel. Jadi, whatever the value dekat sini will be the same as this one. Jadi awak kena tahu konsep ni. Yang bergerak-gerak ni. V equals to V1 equals to V2 equals to V3. Okay, jadi perlu kira apa-apa tak?
Tak.
Tak perlu. Berapa jawapan dia?
110. 110.
Yes, 1104. Mana dapat?
Dalam soalan.
Nampak Ya. Jadi kan, rasa susah ke soalan ni? Dia tak susah. Kalau awak dah tahu dah dia punya konsep-konsep yang penting. Okay, yang ni calculate the resistance of the filament of one of the lamps. Okay, baca betul-betul. Dia bukan nak effective resistance, dia bukan nak total resistance. Dia nak the resistance of one of the lamps. Jadi, what should you do? Okay, kat sini berapa markah? 2. So, what do you think the 2 marks are for? Kita nak tengok balik tadi. So just now I wrote a few formula. Okay, which formula can be used right now?
VIR.
Yes, kena guna V equals to IR. Yang lain tak boleh. Okay, because we want the R. So berapa? Okay, first we write down. Perlu tulis tak? Ya, wajib tulis IR. Dapat 1 markah kat sini. Tulis tu pun lepas tu markah je. Janganlah tak tulis. Jadi, what do you want? Now you rearrange the formula. Okay, lepas tu rearrange ni tak dapatlah markah. R equals to VI, V over I. But this is for you lah, easy for you. Jadi, do you know the voltage? Yes, 110 volt. Do you know the current for each lamp? just now tadi?
0.545.
545 amps. So you tekan calculator, what do you get?
201.83.
Okay, 201.83.
0.83.
What's the unit? Ohm. Okay, tulislah balik dekat sini. Alright? Ataupun you can round this off lah sebenarnya, dapatlah 202. Katakan 200 boleh. Alright, next. Another lamp X has a filament with twice the resistance. Okay, so tadi kita ada ni R, resistance dia R. And then we have a new lamp. So now, ni lamp 1, new lamp, kita ada double. In the circuit, the material and the temperature of filament in lamp X is, oh ni X lah. Okay, so this is X. In table 7.1, tick any box in the right hand column that shows a possible difference between the filament of lamp X and a filament of one of the lamp in the circuit. So which one will you tick? Do you understand the question? Siapa nak tolong mudahkan soalan ni? Okay, dia kata tick any box that shows possible difference. Possible difference between the filament X and just now. Ada beza tak antara these two?
I do.
Ada. So the first one is the X has twice the length. Maybe. Betul ke tak? Yep. Maybe kan? That's why lah. That's why lah dia ada, kita dapat 2R because you know already resistance dia punya one of the factor is the length. So if you increase the length, dia berkadar terus. You increase the length, you increase the resistance. Okay, jadi apa lagi? It has 1/4 of the area. 1/4 of the area maksudnya tadi area dia macam ni, sekarang area dia 1/4. Makin besar ke makin kecil?
Makin kecil.
So tadi macam ni, kita dah kat sekarang ni makin kecil lah. 1/4. Boleh lah, boleh lah. Tapi betul tak macam tu?
Tak.
Mungkin, tapi is it 1/4? Tak, sebab dia ada directly proportional. Okay, balik pada formula tu. Okay. So that it has half of the area. Adakah half of the area pun?
Betul.
Okay. Macam mana awak dapat ni? So salah satunya by calculation lah. Ada calculation dia. Ada siapa nak tunjuk tak macam mana you calculate this one? So awak boleh dapatkan daripada sini ya. R directly proportional to 1 over area. Okay. So kalau kita ada 2R, maksudnya area ni macam mana? Dia separuh lah. Kan dia inversely proportional. Jadi dia terbalik macam tu. Okay, yang the rest tak boleh. Sebab has 2 times bigger this one, larger area. So the larger the area, the smaller the resistance. Okay. Now we are done with question number 7. Okay, then kita tengok question number 8. Figure 8.1 shows a positively charged tube of insulating material. The tube is fixed to a piece of wood that is floating on water. Okay, IGCSE macam ni, dia banyak cerita dia. So where is the cube? So that's the cube. Okay, and then this is a piece of wood. The piece of wood is floating on water. And then ada a negatively charged rod ni is held above the piece of wood and brought close to the cube. Dia close, dia tak sentuh tapi dia brought close. So what happened? Any movement? So dia kalau tak pernah experience mungkin you kena fikirlah what happened right now. So soalan kata explain any movement. You should talk about any movement. Okay, siapa yang move dia tanya? Bukan the charge but the wood. So is the wood, will the wood move? So this one agak susah sikit soalan ni. Macam mana ni? So first you need to know this one negative, this one positive. And then what about them? Negative and positive.
Attract.
They try to attract. So you can write first that one. Itu yang masuk, itu yang come across to your mind first kan? So you tulislah opposite charges. Dia kata explain kan? Opposite charges attract. Okay, so what happened? Bila dia attracts, but however, although ada attraction dekat situ, okay, but they are not touching. And this charge ni pun not touching with the wood. Okay, so sekarang ni dia tak melekat, tapi dia akan bergerak. How it moves? Jadi awak kena cakap lah. The wood, the piece of wood tu dia tend to move kan? Move towards siapa?
The rod.
To the negatives. Mention lah. Okay, rod pun boleh. Rod tu, so we have only one rod, so it's okay if you write towards rod. Ataupun you kena katalah negative rod. Or you can simply write the wood, the piece of wood moves towards the right. Sebab apa? Sebab the piece of wood tu dia tengah pegang, dia tengah dia hold this one. And that purple one tu adalah positive. So seolah-olah dia pun ada positive charge. Now, figure 8.2 shows two cubes of insulating materials. Jadi kalau baca soalan, awak bacalah. Tengah buat exam ni kan, two cubes. What are the two cubes? Macam banyak je cubes ni. Dia kata, so these are the cube and cube. Okay, one is positive, one is negative. The cubes are fixed to a piece of wood that is floating on water again. Charged rods are held above the piece of wood and brought close to the cubes as shown. So tadi kita dah experience satu situation. Ini dia tambah lagi. Jadi what happened?
Opposite charge attract.
Yes, okay, again kita kata now. Tapi kan tadi itu kita dah jawab dekat sana. Okay, kalau awak nak tulis, okay, katalah awak kata opposite attract. Opposite charges attract. And then?
Dia pusing je.
Dia berpusing, betul. Kenapa dia berpusing? Okay, first kan dia kata what happened. Macam tadi ni, mana yang state, mana yang explain. Faham tak? Kalau dia kata state, ni jawapan dia. Dia kata state, you kata this is the answer, moves toward. Tapi bila dia kata explain kenapa, so this is the answer. Nampak tak? Now, awak dah tahu tadi, kita dah tahu tadi opposite charges attract. Sekarang ni what happened? State what happened. Tadi kawan awak mention, cikgu dia berpusing ke? Yes, dia berpusing. So awak kata wood floats kan? Ataupun wood rotates ataupun turns. Rotates. Okey, kenapa tu? Siapa yang jawab tadi? Kenapa rotates? Yang ini, okey tadi kan ceritanya yang ni, this one dia ke kanan. Tadi kenapa?
Positive to negative.
Ya, attract. Okey, sekarang ni, now katalah kita ada, saya besarkan, kita ada positif sahaja. What happened to the wood?
Dia akan gerak ke arah negative root.
Like this, right? What happened if we only have this part here? What happened to the wood?
Opposite dari yang tadi.
Yes. So awak nampak kita ada seolah-olah ada two different directions. So that causes the wood to rotate. Dia nak ke kanan tak boleh, dia nak ke depan, macam ada tarik ke belakang. Dia nak ke belakang, ada tarik ke depan. So last dia rotate. Jadi what's the answer? How do you explain that one? Jadi jawapan awak dah bagi, state tu dapat markah. Yang ini tak ada markah walaupun yes, that's correct. Tapi itu kita dah tanya tadi. Sekarang ni, how do you explain why it rotates? So, balik-balik pada soalan ni. So, these are about charges. Okay, kita ada charge, charge, charge. So, what do you know about charge? Okay, so this is also in topic electric. Remember electric? Okay, and electric also we have force, electric force. Do you know? And then electric pun kita ada field. What else? What other physical quantity dalam tajuk electric? Kita ada force, kita ada field, kita ada apa? Potential difference. And then kita ada electric force, electric energy. Okay, so itu semua electric. So now the question is actually about electric what? Electric field ke, electric energy or electric force?
Electric force.
Yes, it's about force. Jadi kalau awak recall tajuk force dulu, when we talk about force, okay, force kita ada force yang rotating force kan? Ataupun kita ada equilibrium force. What do we mean by equilibrium force tu? Macam itulah. Jadi kat sini you need to talk about the force first. Okay, ada force upward ataupun force opposite sides. Jadi awak kata apa ni? Two forces. So kita nak these words. The term force tu mesti ada. Two forces cause rotating object ni maksudnya what kind of force kita ada?
Turning force.
Do you remember turning effect? Dalam tajuk force. Other words kita panggil turning effect ni, sometimes kita call it moments. Remember? Jadi kalau kita ada objek, kita ada level macam ni, kita ada fulcrum. So sini ada load. I ask you, kalau kelas saya, I ask you to do the experiment, bukan to watch an experiment kan? And then I ask you to write a report. Did you watch this video yang prepared by Cambridge tu? Ada kan? Jadi if you put a load here, this is a load, so this will cause the lever to move anti-clockwise. And then kalau awak push, you letak another load, so this one will make the lever rotate clockwise. So kat sini ada rotation, kat sini ada turning effect. So these are the answers. Okay, kenapa dia rotates? It's because of two forces causing turning effect. So that is how you explain. Simple je kan? Tapi kena recall lah apa yang berkaitannya. Jadi kadang-kadang orang ingat, charge dia tajuk voltage dia ke, awak nak cari current dia ke, tak ada. Kat sini is about static charges. In terms of simple electron model, describe the differences between conductors and insulators. Okay, so ini basic concept atau tajuk electric ataupun charges. Are there differences between conductors and insulators? Yes, they are different. Okay, so what do you know about conductors?
They can conduct electric.
Betul. It can conduct electrics. Tapi itu tak boleh jadi jawapan. Kenapa?
Sebab tak in terms of simple electron.
Yes, dia nak terms of electron. So you need to talk about electrons. Now, awak belajar dalam chemistry kan about freely moving electrons in metal. Betul?
Betul.
Okay. Jadi dalam fizik pun sebenarnya ada part ni. Mungkin awak dah tak ingat ke ataupun belajar sekejap ke ataupun cikgu mention sikit so that you don't remember. So what can you say about conductors? Conductors have
Free moving electron.
freely moving electrons. Okay. So this however, insulators
Doesn't have.
no. Yes. No free moving electrons. Itu je. Cuma kadang-kadang student dia salah lah. Sebab dia tak cakap in term of simple electron. Dia pergi cakap tadi. Yang satu conduct, satu tak conduct. Okay, now drawing. Okay, draw the electric field pattern around a single point positive charge. Wow, this is easy. How do you draw this one? So this one positive. Dia hanyalah macam tu lah. Are these enough? Kan awak kena buat dia macam ada radial lah kan. So buat dia satu and then kena lurus and then not only lurus dia touch the center ataupun the circle tu. Okay. Then awak kena tambah lagi. Outwards or inwards? Upwards. Okay, and kalau soalan tu negatif, it opposite. And then awak kena tahu jugalah yang lain-lain tu kalau kita ada bar dengan negative charge. Macam mana rupa dia? Okay, buat sini. Cukuplah 3. Cukup ke 3? Tak cukup. Awak kena draw sikit sini. Tapi sini ni awak kena buat dia curve. Kan? Okay, ada arrow tak? Kalau for this one. Ni kena touch yang ni salah ni sebab tak touch. Ni this part here. Jadi what is the arrow? Arrow dia from where to where?
Positive to negative.
Okay. Right. We are done. Okay, question 9, tajuk magnet. Figure 9.1 shows a permanent bar magnet next to a circuit that contains a coil and a galvanometer, suggests a metal from which the magnet is made. So you need to know this one ya. Ada 3 jawapan. What are the possible answers?
Steel.
Okay, is it steel? Okay, boleh steel lagi? Apa lagi nama-nama lain bagi, bukan nama, magnet boleh dibuat daripada apa? Steel or?
Nickel.
And another one, C.
Cobalt.
Yep. Right, and explain why there is a current in the coil. The magnet is moved. Ini tajuk apa ni? Electromagnetic
Force.
Induction.
induced. This is about induced electromagnetism. Anybody remember why do we call this induced electromagnetism? Induced means dia tak ada, kita nak adakan, kita inducekan dia, kita hasilkan apa. Okay, so for this one, we want to induce current. Apa saya ni je? Currents. Induced current ataupun we want to induced EMF. So now macam mana ni? Now, the magnet is moved and to the left and inserted in small distance to the coil. The galvano deflects briefly and shows that there is a current. Explain why there is current in the coil. So you tak perlu cakap, okay, untuk topik induced electromagnetism, okay, apa yang awak kena tahu tentang induced electromagnetism, guys? Apa yang awak kena tahu tentang induced electromagnetism?
Kena ada conductor.
Yes. Jadi kita nak tengok macam mana kita ada induce tu. So final answer dia sama ada kita induce EMF ataupun kita induce current. Tapi what makes this one? Apa yang menjadikan kita boleh induce ni? So ingat kan kita ada change of magnetic field lines. Jadi sekarang ni apa yang menyebabkan change of magnetic field lines? So there is change because there is cutting of magnetic field lines ataupun magnetic flux. Kenapa ada cutting of magnetic flux? Apa yang awak buat? Ada movement, ada relative motion. So when we talk about this relative motion, it's either maybe you move the magnet or you move the coil or wire or you move both of them. Okay, so those are the three possibilities yang motion. So jadi macam ni lah dia soalan tu boleh jadi mana-mana. Sama ada daripada motion, dia tanya daripada motion macam mana the motion induce EMF ataupun you are asked to explain this way. Mana-mana boleh. Tapi dia punya konsep dia first mesti ada relative motion. Siapa yang move? Either one. Kalau tak ada movement, tak adalah cutting of. So bila ada movement, there is cutting of magnetic flux. Kenapa tu? Jadi kalau tadi kita tengok, this is the conductor. Ada coil. Okay, actually, if there is the coil, nothing happen to the coil. So there is no magnetic field lines. Betul tak? Nothing. It's just a conductor connected to galvanometer. Nothing is induced. However, if we have a permanent magnet, okay, so let's say this is north and south. What do you know? Ada dekat north, dekat permanent magnet, but you cannot see it. Apa yang ada pada the magnet? Dia ada magnetic field lines. Dia ada magnetic field. And then kita ada imaginary lines tu yang menunjukkan ada magnetic field. So we call this as magnetic field lines. Okay, so this is how you draw if you are asked to draw. Okay, can you tell me the direction from north to south or south to north?
North to south.
Okay, north to south. North to south. How about this way? Yang ni kat sini? Dekat north ni arah anak panah dia? Arah anak dia pun mana? Inwards or outwards?
Outward.
Okay. Oh. So dia adalah outward and then ini masuk. Jadi sini pun masuk. Now, sekarang ni there are magnetic field lines. Tak ada perubahan sekarang ni pada magnetic field line. Nobody touch them. Okay, boleh faham? Now, what happen kalau saya ambil ni, macam mana nak buat menunjukkan dia macam ada pergerakan. Okay, sekarang ni kan saya ambil, saya masukkan sini. Ambil, masukkan sini. What happen? Macam ada benda tak yang mengacau magnetic field lines itu?
Ada.
Nampak tak? Jadi kita kata kat situ there is cutting of magnetic field lines tu. Nampak tak macam seolah-olah ada cutting of magnetic field lines? Nampak kan?
Nampak.
Okay. So when there is cutting of magnetic field lines, what happen? There is, apa dulu saya kata ketiga? Ni tadi statement tadi ni, ingat tak bila ada cutting apa? Ayuh. There is change of magnetic field lines. Bila ada change of magnetic field lines, dan kat situlah nanti awak nampak galvanometer punya needle tu akan bergerak-gerak. Okay. So back to this question. So now you know what to write here. So what do you need to write? First,
There is change in magnetic field line.
yes, change, or there is change of magnetic field lines. Therefore, what happened bila ada change of magnetic field lines? Ada cutting of magnetic field lines. Sebenarnya ni benda yang sama. You boleh cakap antara salah satu ataupun nak cakap dua-dua pun, no problem. Okay, and then finally apa yang penting kat sini? Dia dua markah tu yang mana markah dia?
Cikgu,
Ya,
cutting tu apa?
cutting tu pemotongan. Awak macam bayangkan tadi, nampak tak dia macam potong? Alamak,
Apa yang dia potong?
Macam mana ya? Tak, saya nak tulis macam. Alamak, dia dah potong dulu. Tadi kan, sekejap saya sekejap. Tak boleh lah. Kalau saya kena padam balik. Macam ni lah. Sebab ada orang tanya ni kan. Oh, kau tengok ni I'm talking about the magnet. Sebab sekarang ni magnet yang bergerak. Sekarang ni walaupun the magnetic field lines tu hanyalah imaginary. Awak nampak tak macam coil tu berlanggar dengan line purple tu. Nampak tak? Yang tanya
Nampak.
tadi, nampak tak? So kalau lah dia macam benda yang benda maujud kan, benda yang awak boleh pegang line-line tu, dia berlanggar tu. And katalah coil ni macam boleh ada pisau. So macam seolah-olah dia memotong line-line di purple tu. Faham tak?
Dia macam berlanggar.
Dia berlanggar tu, dia macam kalau katalah yang warna hitam punya line tu, coil tu, dia macam pisau. Kalau dia pisau, dia macam memotong lah yang purple tu, betul?
Betul.
Kan? Okay. Jadi kat situ dia ada, itulah kita kata cutting of magnetic field lines tu. Dia tak adalah cut betul-betul tu. Tapi sebabkan dia imaginary line tu macam boleh hilang, dia macam boleh magic lah. Ada, kejap tak ada kan line tu kan. Kejap arah mana, kejap bertukar arah. Jadi kita boleh potong-potong gitu lah macam tu lah. Dia bahasa literal lah, bukanlah macam directly macam maksud dia. Okay, so tadi mana? Saya dah terpadam ke? Oh, there is change of magnetic field line. So bila ada change kat sini maksudnya tadi ada cutting of magnetic field lines. So finally soalan nak kata apa? Macam mana dia ada deflection tu? It's because ada induced E and F ataupun induced. Okay, usually kita kata EMF lah, kita tak kata current. Okay, so 2, 3, 4. Jadi kat situ yang jadi jawapan adalah this part and this part. Ataupun ni dengan ni, mana-mana. Alright. And alright, so dapatlah dua markah. Markah dia kat mana? Sini atau dua ni mana-mana ni ataupun ni. So, dapat dua. As the magnet is moving near to the coil, end Q of the coil behaves as a magnetic pole. Mana Q ni? Alright, and state the polarity of NQ and explain. Because kat state awak kena explain. Okay, sekarang explain. Apa jadi? North to moves closer to Q. What happened? So this is our Q. Q jadi north or south?
South.
Yes, kita guna Lenz's law. Do you remember about Lenz's law? Okay, Lenz's law states that, awak tak perlu tahulah tapi kita gunakan, untuk tahu tu kita gunakan Lenz's law. Macam mana cara menggunakan Lenz's law ni? Okay, caranya ialah, okay, Lenz's law ni apa? Lenz's law kata, ni for your, okay, the direction, the direction siapa? Ada banyak benda ni. Okay, but Lenz's law is talking about the direction of induced current. Okay, maksudnya if you want to determine the direction of induced current, you use Lenz's law. So the direction of induced current is such that always opposes the change producing it. Now, what is the change producing it? Okay, sekarang ni, you apa changes yang you buat? You gerakkan the magnet. Sekarang, sepatutnya magnet ni dia static macam tu. But you do some changes. You push it, ni, awak masukkan dia ke dalam. Seolah-olah the change you make ni ialah change yang you buat ni seolah-olah, what do you say? Dia attract. Betul tak? Seolah-olah north tu ataupun the bar magnet attracted to the coil. Now, do you get it? Do you understand what I'm trying to say? Faham Okay, so that's the first thing. So seolah-olah dia bergerak, ada attraction dekat situ. However, when you read lagi sekali, the Lenz's law ni, dia kata the direction is such that always opposes. Jadi kalau oppose to the attraction tadi, what is it? Tadi kalau dia pergerakan yang kita buat, dia attract. Tapi oppose attraction tu, apa yang oppose attract? Repel. So dia repel. Ni oppose ni. Seolah-olah dia repel. Jadi kenapa dia jadi kalau seolah-olah dia repel ni, so kalau you know about conductor, tak pernah tak nak ubah-ubah. So kalau you tahu about bar magnet, kalau repel maksudnya if this is north, this is kalau repel. Kalau sini north, sini
North.
kalau repel.
North.
North.
North juga baru dia akan repel. Faham tak? Jadi what's the answer? The answer is NQ is a N-pole. N-pole. Sekarang you explain kenapa. Nak cakap pasal Lenz's law pun boleh. Awak tulis je apa dia Lenz's law ni. Ambil semua ni. Kan? Lenz's law states that. Copy. Letak sini. Tapi kalau awak faham lah dan awak boleh buat statement tu. Tapi kalau awak tak tahu statement ni, mungkin awak tak dapat jawab. Jadi simple je ataupun awak boleh, kalau awak faham apa yang saya cakap maksud Lenz's law tadi, awak tulis dalam perkataan sendiri. Jadi sebenarnya apa yang berlaku ni? Apa maksud ni? Maksud yang ni ialah ada opposes, ada repel. Seolah-olah macam ada repulsion kat situ. Apa yang repel? The magnet kan? It is as if the magnet repel the coil. Atau the magnet tu we refer to the coil tu lah. Magnet tu kita refer pada coil and then kita kata repels the north. Kenapa kita kata magnet ni? Sebab if there is current, okay, do you still remember about electromagnetism? Okay, kalau saya buat macam ni kan, so tak nampak ada magnet kat situ. So if I change this one, kalau saya tukar ni kepada, it's already 9:56. Kalau saya tukar ni kepada battery ataupun drive cell, what happen? Current flows. And this is the direction of conventional current. Okay, ada current flow. So bila current flow, current flow through a conductor. So this is a conductor. You know that when current flows through a conductor, what happened to the conductor? Ada electromagnetism. Mana ni? Aduh. Ni. Okay. Dah belajar banyak ni. So banyak-banyak. So kalau ada conductor, kita ada conductor and then ada current flowing through the conductor becomes electromagnet ataupun the conductor tu yang menjadi temporary magnet. Jadi kat sini dia seolah-olah magnet juga bila ada current flow. Itu sebab kita kata dia macam menjadi magnet berjumpa dengan magnet lah ni. Macam magnet jumpa dengan magnet. Tapi magnet current yang tadi tu is just an induced current. So faham tak Lenz's law tu? So jawapan dia boleh jadi begini ya. It's either you write down the Lenz's law punya statement ataupun you mention apa yang awak faham daripada Lenz's law. You are not expected to untuk IGCSE awak tak perlu pun nak hafal maksud Lenz's law tu. Tapi sebenarnya pemahaman terhadap Lenz's law tu membantu you jawab tentang electromagnetic induction. Okay, suggest two ways in which the deflection galvanometer can be reversed. Senang saja, you tukarlah direction of the conductor tu, awak tukar ataupun awak kata awak masukkan arah lain. Kan tadi awak masukkan the magnet into the coil. So sekarang ni awak alihkan south yang masuk dulu. Okay.